everyone, welcome to this video. In this video, let us understand a series RC circuit when AC voltage is applied. In the previous video, we have seen RL circuit. In the similar manner, we can analyze this RC circuit also. Here resistor and capacitor connected in series. We are applying an AC signal. So V is equal to Vm sin omega t we are applying. If we consider the pure resistor and pure capacitor separately, and if we apply an AC voltage in the resistor, I and V are in phase. So the two signals are in phase, and if you write the phasor diagram, this is V and this is I through the resistor. Similarly, if we take the capacitor, in the capacitor we know that current leads the voltage. If you compare the current and voltage, if you take this as voltage, current will be leading, means current direction will be like this, means we will be having a phase difference of 90 degree. Now we will be having the combination of these two. So we need to consider the voltage across VR is VR. So the voltage across the capacitor we can consider as VC. Now we need to consider the current flow in this direction, that is I. So if you write the phasor diagram for this, VR, VC is separately considered as voltages and current will be same across through those two. And the phasor diagram look like this. Since current is common between those two, I am taking current phasor as a reference. First I am going to write the current, and then if we put VR will be fall on the same axis, since VR and I are in same phase. And with respect to the C, the voltage in the capacitor will be VC. It is having a 90 degree phase shift with the current. The total voltage V, if we put, this is in this direction. So the angle, if we take, this is what the power factor angle is. So current and voltage of this circuit, if you consider these two signals, they are differ with phi angle and current is leading. So I can write this I as Im sin omega t plus phi, right, for the current, since it is leading the voltage, right? Current is leading, voltage is lagging. So if we write the voltage triangle by considering these three, I will put VC here and this is my V. So total V can be written as V is equal to under the root, it is VR square plus VC square. And we know that the angle between the two, current and voltage, will be phi. And if we write the expression for phi here, it is again tan inverse of VC divided by VR. And we can write the triangle for the resistance and reactance of the capacitor and the impedance is concerned. So here I can write the expression for impedance. It is root of XC square or R square plus XC square. And what is XC here? It is the reactance of the capacitor, and R is the resistance. And here also this is the angle between the voltage and the current axis. If we write phi, it is here tan inverse of XC divided by R. Here also XC is the reactance of the capacitor. Now we can get the expression for the average power. The average power is going to be calculated by using the power instantaneous value first. P instantaneous is equal to V into I. Here V is Vm sin omega t into Im sin omega t plus phi. Why? Because here current is leading the voltage, right? So again we can use sin A sin B formula here. Sin A into sin B, in terms of cos, it is Vm Im into cos phi minus cos of omega t plus omega t 2 omega t plus phi. Since here we have plus phi, so divided by 2. So this becomes Vm Im divided by 2 into cos phi minus Vm Im divided by 2 into cos of 2 omega t plus 5. Here we will be having 2 omega t. So this is the instantaneous value. If you want to calculate the average value, P average will be represented as integration of 0 to 2 pi, the whole expression. This expression I am going to write as it is. And in the first expression you can observe we will be having Vm Im divided by 2 into cos phi. Here we will be having minus Vm Im divided by 2 cos of 2 omega t plus 5. So 2 times the frequency will be there. So for the complete cycle, if we integrate from 0 to 2 pi, this parameter becomes 0. So P average is 1 by 2 Vm Im into cos phi. This is the expression for average power.